Hi everyone, welcome to this new video, chapter 15, Monopoly. We're going to work throughout exercises from 1 to 6. Remember, this is the book of Gregory Mankiw, Principles of Economics. So the first question says, publisher faces the following demand schedule for the next novel from one of its popular authors. So here we have the publisher. Here we have it's important to understand that here we have the price, which it decreases here, and here we have the demand, the quantity demanded at this kind of price. So naturally the quantity demand increases once the price decreases, and here a book provides that normal here with another three zeros, but I'm going to avoid that in order to that's the simplest possible. So we identify that as 1,000. So if the book says 100,000, in this our table is going to be 100. It's going to be definitely much easier. And this is like the law of demand. So when the price goes down, naturally quantity demanded will increase. Then the question says, first they said that the author is paid 2 million to write a book, and the marginal cost of publishing the book is a constant $10 per book. So immediately when we have that, we're going to show how we have to represent that in the table. The first question in that point says that compute total revenue, total cost, and profit at each quantity. So we need to verify that. So first, total revenue, remember, is going to identify by the quantity that you sell times the price. So if the publisher sells a book in $100 each book, they're going to sell 0 units. So it's going to be 100 times 0. Then 90 times 100 is going to be 9,000. And remember, this one is naturally 100,000 times 90 is going to be 9 million. So it's going to be this one 9,000, and here another 3 zeros, so it becomes 9 million. Okay, here we have 9, then we have 16,000, and so on and so forth. So we verify here something really interesting. First, when the price is 100, the total revenue is going to be natural 0. At the same time, when the price is 0, it's kind of free. You have the total revenue 0, because even you sell 1,000, you provide them by free. That is going to be 0. We verify here the maximum total revenue of this one is the quantity 5 500. Okay, it's going to be like the maximum total revenue that this publisher has. Then we already have total revenue is done. Then we need total cost, but remember, total cost, it divides into fixed cost and variable cost. So the fixed cost, remember, it doesn't change when your quantity varies. So in this case, your quantity varies. So here we have the part that you have 2 million to write a book, which is going to be the fixed cost for the publisher. So it's going to be 2 million each. But remember, because I'm keeping that in thousands, so it's going to be 2,000 plus 3 zeros is going to be naturally 2 million. So for this reason, I still keep them as 1,000 to avoid a lot of zeros in our table. So all the quantities, they will represent the same fixed cost, because the fixed cost doesn't change when the production vary. So here we have the variable cost. Remember, when there is zero books produced, then your cost is going to be 0 because you don't produce anything. So this one is going to be kind of 0. So we represent that here. Then we have here this one 1,000. It comes from quantity demanded in 1,000, okay, times 10 is going to be 1000. But remember, it is still in thousand, because if we have here in thousand, it's going to be 100,000 times 10 is going to be 1 million. So it's going to be this one 1000 plus this 1000. It represents another three zeros. Remember, just for avoid to like full all table with zeros. So it's going to be 1000. Then the other one is going to be exactly the same. 200 times 10. So just you add another zero. It's going to be 2000, and so on, so forth. So you already have here variable cost and the fixed cost. So naturally, if you sum them, you will have at the end of the day the total cost. So it's going to be this one 2000 plus this one is going to be 2000, 2000 plus 1003, and so on and so forth. Then we already have here the total cost. It's done. Then the profit. What is the definition of profit? What you sell minus how much it costs. It costs to you. So then it's going to be the total revenue minus the total cost. It's going to be 0 minus 2000. Naturally, because we have here thousands, the profit is going to be thousands again. So that is going to be minus 2000, which is going to be at the end of the day minus 2 million, because you don't produce anything, but you still need to pay to the author. So that is going to be this one, because you don't sell anything. Then you have this one, which is going to be 9 minus 3, then 16 minus 4, 21 minus 5, 24 minus 6, 25 minus 7, 24 minus 8, 21 minus 9, 16 minus 10, 19 minus 11 is going to be minus, and then it's going to be this one, minus 12. Then the question, what quantity would a profit maximizing publisher choose? Is going to be the quantity that the firm will produce is going to be 500,000. Okay, it's going to be 500,000 of books, because they represent the highest. It's going to be 8,000 thousands. So it's going to be at the end of the day 18 million. Price would it charge? So the publisher charges $50. Okay, then B, marginal revenue. Recall that marginal revenue is equal to, in the numerator, delta total revenue, in the denominator, delta Q. How does marginal revenue compare? So first, before starting explaining that, we need to remember that marginal revenue is how much your revenue is going to change once you sell an additional unit. This is the basic definition. Naturally, most of the time in the denominator, the change is 1, because you just change the quantity one by one, so denominator is going to be 1. In this case is different, because at that time the quantities, they don't vary one by one, they change by 100,000. Okay, so the variation is going to be in 100,000. Then for this reason the denominator will be different. Delta, it comes from the Greek alphabet, but in economics and in maths in general, it represents change. So then we're going to try to have to compute this marginal revenue. So here is all the table that we already filled in the previous point, but we just add a new column, which is going to be marginal revenue, again in thousands. So here we have the first is going to be 0. Why? Or maybe this hyphen, because we need to compare one with another quantity, and here we start from 0, so you don't have like any point of comparison before that, so it's going to be 0. Now we're going to compare this one, okay, the second one. So the second one is going to be the marginal revenue of selling 100 instead of 0. So then in the numerator is going to be the total revenue when you sell 100 minus the total revenue when you sell 0 units, and then the quantities of 100, which is going to be 100 minus quantity. Remember, this is all in thousand. So then it's going to be the total revenue when you sell 100 units. It's going to be 9,000. This one minus 0 over 100, which is going to be here, minus 0. So then this one is going to be just 9,000 over 100. You cancel out the 0 with the zeros here, 2. So it's going to be 90. Sorry, this is going to be 90. Okay, 90. Then you proceed exactly the same. So the next one is going to be basically to be 16. Going to be like 16 minus 9 plus 1 0. So it's going to be this one 70. This one is going to be what? 50. But you can put like that, but it's going to be exactly the same. This one is going to be 24 minus 21 and plus 1 0. It's going to be 30. And so on and so forth. Here we have negatives. Okay? Then we already verified that. So something interesting you have here, that as you remember in the explanation during the chapter, the demand, which is going to be exactly these values in price. So remember, you have the price and quantities. So this one, we have this value, and the marginal revenue exactly the same. It starts from the same point of the demand, and then it increases faster than this one. So the slope of the marginal revenue is like more inclined. Okay, this one is going to be the marginal revenue. Then graph the marginal revenue, marginal cost, and demand curves. At what quantity? Okay, first, before reading that, we need to graph that. Obviously, you can graph that with a piece of paper, and it's going to be natural fine. You will put in the y-axis the cost, and the x-axis you will put the quantities. I'm going to help you how you can graph that in Excel. So here we have the same graph, okay? The same graph that we have here. So we need to represent what? We need to represent the marginal revenue, marginal cost, and demand curve. So marginal revenue is going to be this one. We need to represent marginal cost, okay, and the other one, the demand, which is going to be natural, this one. I want to show you why. Okay, then I'm going to take advantage of this Excel to help you how to compute them in Excel. So here, total revenue is going to be just multiplying the price times this revenue, okay? Sorry, the price times this quantity is going to be this one. Okay, how you can represent that? So you just put the equation here. So we are going to suppose that it's not here. Okay, it's going to be here. Then you go here with your mouse. It's going to be this one in the corner, and you make double click, and it fills automatically. Okay, then the fixed cost is going to be exactly the same. It's going to be 2,000. We're going to avoid this one, and we're going to make double click here, and it fills automatically. Then the variable cost, remember, is going to be the multiplication of 10, okay, because this is the value times the quantity. Then again, you make double click here, and you have here the result. Then the total cost is going to be the sum of this column G and E. Then is going to be this one plus this value plus this one. Then if you make double click here on the corner, you will arrive. Then the marginal revenue is going to be what? It's going to be C3 in the numerators is going to be total revenue by this quantity, then minus this one over 100 minus this one. And the same, you make just like double click and it goes this one. It fills everything. And the marginal cost is going to be exactly the same, just with the difference that instead of total revenue natural, you will make that with the total cost. F3 minus F2 over this one. Okay? Then the same. Now we need to graph them. How we can graph? So first you go here, insert. Then after insert, you go here with these lines, and you choose this one. Okay, once you choose this one, you need to select data. Then the data is going to be this one. But now you don't need everything, right? So what we're going to make this one? We need to cancel this one. We don't need this one, this one, this one. Okay, this one, no, and no. Then you say remove. Okay. Okay. Then I guess that I did something wrong. So here is going to be the marginal. This one, the values, they are going to be this one, values, those values, and the other one we need to add the other one. The edit name is going to be this one, and the values are going to be this one. Okay, so then we have this fact, and this one, the horizontal, this is going to be the quantity. Okay, this is going to be the quantity, but this one is going to be the quantity, which is going to be this one, right? Okay, great. Then, okay, suppose that like 5, this is not kind of okay, because here it starts from 0 and it goes like that. So we need to change a little bit. So now how we can change? So data, okay. Then we're going to start, instead of this one, we're going to start from when we have values, and this one is going to start the same. Okay, and then this one, they're going to start from when we have values instead of 0, and this one uh, is going to be exactly the same. I just did that because it's probably what is going to happen when we graph that. Then uh, things change a little bit. Here we have kind of the graph that we need. So maybe we need to label the axis. So here we have axis here, laid out here. Let me see here. It's going to be actual titles, primary, and here we're going to add the other one, primary vertical. So this one is going to represent like the cost. Okay, and this one, it will be represent what? Quantity. Maybe something that is, you need labels, right? So then you have here data labels. Maybe you will need the legend better, so you will put like right, maybe maybe it's not okay, maybe it should be better legend. Yeah, let's put like down here. Okay, then which other thing I guess important? I guess that it's like that. So then when we have here, it's going to be like kind of similar to this graph, right? And naturally you put here in 1000, it should be important, and this one with this 0, without this 0. So then you need to change this one. So maybe here, if we can change this one, the format of this one. So then let me verify how we can change that. Here vertical market access cross number, the number, the type. Let me verify here how we can change that. Okay, we did it. We changed this one, and then we have. Okay, then this one should be represented. So now we go back. Okay, to this one. Okay, first we need to compute the marginal cost, which is going to be, as I explained you, the same as in Excel. The change in the total cost, this one, denominator minus this one over this quantity, right? Then we have this one, which is going to be constant marginal cost. Here we have the graph. Here, this one is the quantities. Okay, maybe I missed put them. Here we need quantities. Here we need cost. So here we have first the marginal cost, which is constant, which is the value of 10. Then we have the marginal revenue, which is going to be this one in blue. As I said before, the slope is higher than this one, is more inclined. And here is the quantity demanded. Okay, this one is kind of orange. Then, what quantity do the marginal revenue and marginal cost curves cross? What does this signify? So here we have they cross the marginal revenue with the marginal cost when the quantity is 50. And what? Remember what? This is the maximum benefit that the firm, the monopolist, the publisher has. So this is an important part. How we can understand that? If we go to the left part of this one, it means that the revenue that you have is higher for the next unit, is higher than the cost that you will have of publishing one additional unit. So you can move forward. Even here your revenue is higher. But what about if you go here to the right part? It's going to be completely opposite, because what you will receive is going to be lower than what really cost you. So for this reason, this gap is not going to be okay for you. So for this reason, you converge to this point when exactly this unit, it provides no cost at all, no benefit at all, no profit at all. So for this reason, this one is going to maximum. Okay, this is going to be the maximum of a monopolist. Okay, then have shade in the deadweight loss, explaining what this means. Basically, the deadweight loss, as we saw in previous videos, is this kind of loss that is represented because of missed transaction that they cannot be performed as we had before. So all these consumers that they potentially will buy to a lower price, they will not buy anymore due to this higher price that the social efficient. Remember, this social efficient, this is the quantity where the company, they don't make any economic profit. So this one is going to be lower than the monopolist. So then, for this reason, we can represent that this deadweight loss is going to be this blue triangle. All these transactions that all people that they can buy with a price lower than 50 and higher than 10, then they will not buy anymore due to the higher price. So this is considered the deadweight loss. Is the same effect that we have as we had in the government taxes. So then the equation says if the author were paid 3 million instead of 2 million to write a book, how would this affect the publisher decision regarding what price to charge? Explain. So before moving that, this is our final output of the previous result. So before moving that fact, the point that we have with a higher fixed cost, if we don't have any loss, is going to be any it doesn't matter. It's not a matter for the publisher, for the monopolist, because remember, people of think of marginal decisions. So then the marginal decision will not change because it's going to be a fixed cost which will change. Let's have a look here. So we cancel out this one and we change for this one, for 3,000. Then what else is going to change? Naturally, the variable cost is going to be exactly the same, just the total cost you will add 1,000 more. Remember, 1,000 in our table, but because we labeled that in thousands, it's going to be 1 million. So then if you verify here, your marginal cost is going to be exactly the same and your marginal revenue the same. And remember, if we don't have benefits, maybe the monopolies, they don't produce, but here they still have benefits because total revenue is 25,000, which is going to be in thousands. So then it's going to be 25 million minus 8 million, going to be still benefits. So then the decision is not going to change at all. So remember, every time we change in fixed costs, we just make a change if the monopolies has losses. But in that case, they still earn money. So they will produce still because people think of margin. So then, the same point F. Suppose the publisher was not profit maximizing, but was concerned with maximizing economic efficiency. What price would it charge for the book? How much profit would it make at this price? So remember, when we are talking about economic efficiency, we're talking about kind of a competitive market. And remember, the competitive market, we arrive at the end, the conclusion is we arrive to the price equal to marginal cost. If you still don't feel confident with that, please go back to the previous video of the chapter 14 where we talk about competitive markets, because it would be like really crucial in order to understand that. So then here we have the same graph that we already made, we already did in Excel, and here we have this is the situation of the monopoly when the marginal revenue is exactly equal to the marginal cost, and then you will charge the demand, which is going to be at the price of 50, and then this is going to be the economic efficiency where the price is equal to the marginal cost. So this one is going to be the economic efficiency where the price is equal to 10. So then we're going to prove that. So we have here the situation where the price, which is 10, is equal to the marginal cost, 10. What happened with that result? Naturally, it's going to be like really bad decision for the monopolies because even they have losses. Why? Because the total cost is going to be higher than the total revenue. So this is going to be the profit is going to be negative if they charge the economic efficiency point. Then second point says a small town is served by many competing supermarkets which have the same constant marginal cost. Use a diagram of the market for groceries, show the consumer surplus, producer surplus, and total surplus. So here we're going to represent a normal market that we saw in the previous chapter, chapter 14. So here we have the supply and normal supply, which is like upward shape and upward slope, and here we have the demand with the downward slope. Okay, then we have here a price and quantitative equilibrium. When we find these were like kind of the emptiness of the market where the same quantity produced is equivalent to the same quantity demanded. Naturally, we have in the x-axis we have the quantities, and if the y axis we have here the price. This is a mistake, it's going to be a p. Okay, sorry for that. Then this is going to be this triangle is considered as the consumer surplus, and this one green one is the producer surplus. So remember, what is the definition of consumer surplus? Is kind of saving between quotation mark all this willingness from the consumer side that they don't pay for that. For example, people that they are willing to pay this price, which is not really higher than price star, they won't pay that because the price equilibrium is going to be lower. And the supply is analogously we can consider that kind of profits from the producer side because they are they want to sell a price of even lower, but they sell at the end of the day a price star. So then this is going to be kind of benefit. So this one is what we consider consumer surplus and producer surplus and total surplus. Indeed, competitive economy. We have here the total surplus is the sum between these two. Then suppose that independent supermarkets combine into one chain. So we create a monopoly. So we change from a competitive market to a monopoly. So using a new diagram, show the new consumer surplus, producer surplus, and total surplus. Relative to the competitive market, what is the transfer from consumers to producer, what is the waste loss. So naturally, we already know that the price in a monopoly is higher than in a competitive market. So we can represent that with the same diagram, just with one difference. The price charge at this market is not going to be here. Again, the same mistake is going to be P. Then the price is going to be higher. So here we have the first situation of competitive market, and here we are with one chain. One chain, they will charge because they have what we call in economics market power, so they will charge a price higher to PSR. With remember, this decision is going to be represented where the marginal revenue is exactly equal to the marginal cost, and then all this one is going to be the green part is going to be the consumer, the producer surplus, and this one is the quantity of the monopolies, which is lower than the competitive market, but the price is higher than the price of the competitive market. And this yellow triangle to be the deadweight loss, which is going to be the transfer. So this rectangle is going to be the transfer from the consumer to the producer, and this triangle is going to be at the end the deadweight loss. So this little part of the triangle is what producers they renounce, so they don't have, they give up in some way, and the other one, the consumers, they don't have that, because people from this, like along this part of this line, they won't buy anymore due to the higher price. So then the next question says, Rockabilly has just finished recording this latest CD. His record company's marketing department determines that the demand for the CDs is as follows. Again, we have here in the book 1,000, we have here like 10,000, but in order to avoid to put like a lot of zeros, we just like change here by 1,000, and then it's going to be this 110. And naturally, we verify here how the price goes down. Naturally, the number of cities they increases. Then the first question says, the company can produce the city with no fixed cost and a variable cost of $5 per city. Then find total revenue for a quantity equal to 10, 20, and so on. What is the marginal revenue for each 10,000 increase in the quantity sold? So first, total revenue. Remember, total revenue is the price that you charge to the consumer times the quantity you sell. So it's going to be 24 times 10. It's going to be this one, naturally, it's going to be in 1,000. So this one is going to be 240,000 as revenue. And here we avoid the zeros again in order to have like easier comprehension. We have here 20 times 22, 30 times 20, 40 times 18, 50 times 16, and 60 times 14. Then your marginal revenue, remember, is going to be the change, the numerator, the change in the marginal, in the total revenue. This is wrong. This is going to total revenue with 20, and this one is going to be 10. Okay, so which is the total revenue of 20? It's going to be 440. What is the total revenue of 10? It's going to be 240, and then the quantity is going to be 20 minus 10. So then we have here is going to be 22,000. So this is going to be 20,000, and remember this is going to be blank, because this blank is empty because you don't have any point of reference before that. So then it's going to be 22, this one is going to be 16, this one is going to be 20, this one 80, and this one 40. Okay, this one is going to be the marginal revenue. So this one is wrong again, I'm so sorry. This is going to be 8 and 4. Okay, so this one, as the demand, they start in the same point 22, but it increases faster than the demand. Okay, this is going to be 8 and 4. Okay, then the other question says, B, what quantity of cities would maximize profit? What would be the price be? What would the profit be? Then the variable cost is exactly equal to the total cost in this case. How come? Since we don't have fixed cost. So because we don't have fixed cost, the variable cost is going to be exactly the total cost. The variable cost is going to be 5 per city, so then it's going to be 5 times 10 is going to be 50,000. So we just represent here 50. Then we have 5 times, here we have 5 times 20 is going to be 100. 5 times 30 times 40 times 50 times 60. Then the profits is going to be again the difference between the total revenue minus total cost. Total revenue is going to be 240 minus total cost is going to be 190. This one is going to be 340. This is going to be this one minus this one, 450, 520, 550, and 540. So this one is going to be the maximization, okay, in this part. Okay, when the price is 16 and the quantity sold, they're going to be 50,000. Then, if you were Johnny's agent, what recording fee would you advise Johnny to demand from the recording company? Why? So you need to demand something that makes still profitable the recording company. So then it's going to be maximum 550, because if they charge more than that, the economic profit is going to be nil. It's going to be zero. So for this reason, it's going to be maximum 550. So that case, the economic profit should be zero. Okay, then it's going to be this the maximum. Then the 4 point. A company is considering building a bridge across a river. The bridge would cost 2 million to build and nothing to maintain. The following table shows the company's anticipated demand over the lifetime of the bridge. Here we have the price. As the previous exercises, it works exactly the same. The price goes like down, and the people, the demand, increase. Okay, because which a lower price people will use more the bridge. And again, we have here in thousand in order to make them the computation kind of easier. So the first point says, if the company were to build a bridge, what would be its profit maximizing price? What will be the efficient level of output? Why or why not? So first, we have the total, the fixed cost, which is going to be 2 million. So in thousands, it's going to be 200, 2,000, thousands, so it's going to be 2 million. Then in that case, different from the previous one, we don't have variable cost. So if variable cost is zero, because in nothing to maintain, there is no cost, so the fixed costs, they're exactly equal to the total cost. So here we have the 2,000. Then, which is going to be the revenue? It's going to be times price times the quantity you sold. So this one is going to be 8 times 0, 0, 7 times 100, and then we have again in 1,000. So here we have the total revenue, which it increases, and then it starts to decrease after the price goes to the 3. Then the profit is going to be total revenue minus total cost. This one, that time you don't, no one crosses the bridge, but you still need to pay the investment, which is going to be 2,000. So then the profit is going to be 2,000. It's going to be 2 millions, and then it goes like this. Then at that point, unfortunately, they don't have any profits. Okay, this one maybe is not efficient. Maybe the best decision is not to produce, not to build or construct this bridge. But once they build that, at least they need to suffer the less loss possible, which is going to be this one. Price for the number of people that they cross, they're going to be 400, and then at that time your total revenue is going to be 1,600 minus this one. You will have a loss of minus 400,000. Then this is more loss possible, but it's better not to build a bridge if they can anticipate that. B, if the company is interested in maximizing profit, should it build a bridge? What would be its profit or loss? Then again, this one is going to be the quantity produced, but maybe they should not bridge the they shouldn't bridge like build the bridge because they're going to have like loss for doing that. The other question said, if the government were to build the bridge, what price should it charge? As we said previously, price equal to 4. Should the government build the bridge? As I said before, well, in front of the social, of economic status, I mean, from the social welfare, maybe should be okay because people need that to cross the river and it's going to be mandatory to build that. But in terms of economic part, it's not going to be kind of possible because they have losses. The government has losses if they provide this kind of good to the community. Then we have the next point. Larry, Corley, and Moe run the only saloon in town, sorry. So then Larry wants to sell as many drinks as possible without losing money. So first, the idea is like we need to identify that in a single diagram and we need to identify each decision of each one. And then we need to verify okay, Mo using the single diagram, the saloon's demand curve and Scott profit show the price and quantity combination favored by each of three partners. So here we have the first situation, which is going to be Larry. Larry wants to sell as many drinks as possible without losing money. Here we have the situation of only saloon in town. It brings up in a situation where there is a monopoly because there is just only one saloon. So here we have the cost and revenue, and here we have the demand, and here we have the marginal revenue, which as we saw previously, they start from the same point, but it's like downward, and like the slope is kind of higher. Here we have the marginal cost, which at the end of the day is going to be represented the supply curve, and here we have the average total cost that we saw in the previous video. It is cut immediately or in exactly in the minimum point by the marginal cost. Then the first situation is the case of Larry wants to sell as many drinks as possible without losing money. So remember, the point here, when you have here, when the price equal to the average total cost, then you won't have any loss of money, and you will sell the maximum quantity. It's going to be this one. Why? Because profits, they are representative of the I'm sorry, here I did it in Spanish wrong. This one's going to be total revenue, okay, TR, minus total cost. Then your total revenue is going to be represented by P times Q, and the total cost is going to be total cost. Okay, then you can make kind of trick. You can multiply that by Q, but at the same time you can divide these two terms by Q. So it's exactly the same. You can cancel out here Q, and here you know the total cost over Q. You can represent that as the average total cost. So here, when the price is equal to the average total cost, your profits, they're going to be 0. So then you can sell here until that, when the price is exactly equal to the average total cost. So here we have the average total cost, here we have the demand. So if currently at that time, I'm so sorry, this one is not going to be Curly, it's going to be Larry. Okay, this one's going to be Larry. Then Larry will produce until this point, because at this point they are selling the maximum possible without losing any money. So this one is going to be the income or the revenue, and the total cost is going to be exactly this one, because average total cost times Q is going to be total cost. So this is going to be exactly the same one. Second situation is about Curly, right? Here we have Larry. Okay, Larry wants sorry, here again I did a mistake here. I just mixed everything, but here is going to be Curly wants to saloon to bring in as much revenue as possible. Remember, at that time when we have this one, this marginal revenue, and it is still positive, it means that you sell additional unit and your total revenue will increase. Just when the marginal revenue crosses and start to this negative part of the this one of the Cartesian plan, so we have this one, then total revenue is going to decrease, but at that time you still have that. So when the marginal revenue is exactly 0, it means that you reach the maximum total revenue, which is going to be this situation. So then, according to Corley, Larry, Corley will charge to this point where your total revenue is going to be this one. Even your at that time, your cost is going to be this one, so you have loss. Instead of Larry, which was the previous one, in this case we have losses. So the situation that Carly is saying is even worse than Larry. Larry produces zero profits, Carly produces negative profits, so it means losses. Then the last one, which is going to be a mole, I hope I okay, then it's going to be this one, Mo. Definitely this one, he wants to make the largest possible profit, which is going to be exactly the situation of a monopolist, where the marginal revenue is exactly equal to the marginal cost, and it's going to be exactly this point, okay? Then this one, they have all that price times quantity is going to be all these. It's going to be the revenue, and the cost is going to be this one. So this square is going to be representative of the profits. So Mo is the one who thinks better because it charges when the revenue is equal to the marginal cost. And the last one says, the residents of the town Ectenia all love economics, and the mayor proposes building an economics museum. The museum has a fixed cost of 2,400,000 so 2,400,000 and no variable cost. There are 100,000 town residents, and each has the same demand for museum visit. Quantity demand is equal to 10 minus P, where P is the price of admission. First question, graph the museum's average total cost curve and its marginal cost curve. What kind of market would describe the museum? So here we have the cost, and they are measuring 100,000, okay? And then we have here the quantity measured again in 100,000. Then we have here, if they have a fixed cost of this one, which is going to be 2,000,000 for 400,000, then the cost is going to be that time. For example, if you have one quantity, is going to be what? Is going to be the average total cost, which is going to be 24 over 1. Okay, then this same quantity if you sell just one quantity. Then if you sell two, this is going to be this again, this 24 over 2 is going to be 12. So this is going to be this value when the quantity is close to 0, okay, at that time it will start to this one, and then when you increase, this one is going to decrease because the numerator is going to be stay the same, the total cost is going to be exactly the same, but the quantity will increase. So it's going to be something like that, and actually I should say that it starts from here. So the more quantity you sell, to divide the total cost over this one, but never is going to be 0, just going to be approximate 0. And this one is going to be start from here, from 1, because you cannot, this is the quantity when you can sell like half of entrance, but it doesn't make any sense. Just so maybe it's going to start from here. Then is the average total cost curve. And as you notice, due to they don't have any variable cost, this is really close to a natural monopoly. Then the marginal cost at that time is going to be 0 because it doesn't matter to provide another entrance. So this one, this other white curve, which is actually a straight line, this is going to be the marginal cost, which is going to be 0. Then here we can go to the other point. Then B. The mayor proposes financing the museum with a lump sum tax of 24. It means that it doesn't matter if you go once, if you go twice, you need to pay 24. This is going to be the value that you need to pay for each time you go to the museum, and then opening the museum for the public for free. So it means you can go all days, Then as I said, you can go all days, but you need to pay every year. You need to pay 24. Okay. Then and then opening museum for public for free. How many times would each person visit? Calculate benefit each person would get from the museum. Then measure as consumer surplus minus this new tax. So here we have the curve for one individual. So here, if the quantity is 0, then this one is going to be this P, which is negative, goes to the other side, is going to be P equal 10. If the price is 0, the quantity demanded is going to be 10. So here we have the demand curve of this person. Then here we have the total revenue, which is going to be P times Q. Then this one, okay, I represent here the marginal revenue. It doesn't make any importance here, but I don't know actually what I did or why I did it, but I'm going to explain how we can make the total revenue. So here total revenue is P times Q. The price is represented by, if you go this one, P goes here to the left part, Q go here, so it's going to be 10 minus Q. 10 minus Q times Q is going to be 10Q minus Q squared. Here you can derive this one, so the derivative form of 10Q is going to be 10, and the derivative form is going to be Q squared. So it's going to be 2Q. So this one, when the price is going to be this one 0, at that time when the quantity is 0, this one is going to be 10 again. But this one, when this one is 0, is going to be 10 divided 2 is going to be 5. But actually it doesn't make any relevance here. So just skip that if you understand that. It doesn't make a real relevance. So here we have the consumer surplus. So the consumer surplus, because it's free, you are going to go to the museum 10 times. So this old triangle is the consumer surplus. That is going to be 10, which is going to be the base, times the height is going to be 10, going to be 1,100 over 2, which is going to be 50. Minus the tax that you need to pay is going to be 24. Then your consumer surplus is going to be 26. Then the C question says, the measure's anti-tax opponent says the museum should finance itself by charging an admission fee. What is the lowest price the museum can charge without incurring losses? So they provide a hint. Find the numbers of visit the museum profit for prices 2, 3, 4, and 5. So you can use that, and when you have the profit 0, you will have the result. Or you can go further. You can make that mathematically. So let's go mathematically. So you know that the profits, they are total revenue minus total cost. Then you know that the total revenue is going to be P times Q, and the total cost is going to be this one, a fixed cost, 2,400,000. Then you have that the Q, you can represent Q as 10 minus P. But remember that you have residents where they are 100,000. So it's going to be 100,000 times 10 is going to be 1,000,000, and 100,000 times 1 is going to be 100,000. Then you multiply that. It's going to be this one, P, minus this one, P squared, minus this one. So the idea is like you need to make that like larger to 0. Then this is going to be kind of parable. So it's going to be kind of a mountain like that. So then let me represent here. So if you represent like here, this is going to be like something like that. You have here the profits. Here you have the quantity. So this one is going to be something like that. So we need to find this point, which is going to be this one. Sorry, this one is going to be the price. Which is the price that is lower, that makes that the profit equal to 0. But not true, because this is a square, so we will find 2 points. But we're going to take this one, the lowest. So then you have here just dividing everything by 100 1,000. This one is going to be 10. This one is going to be uh, 1, and this one is going to be 24. Okay. Then you have that making everything negative. Okay. You change this one, the inequality. Why? Because if you have 5 is larger than 4, and you multiply this one minus and this one minus, you have minus 5 larger than minus 4. It doesn't make any sense because it's going to be minus 4 lower than minus 4. So this one is going to be like that. Then we make this one the factorization. So we have this one. We have the square root of this one is going to be p in each parenthesis minus minus times plus is going to be minus, then two numbers that they multiply 24, and when you sum them you have 10. So 6 times 4 minus 6 minus 4 multiplied, you have 24, and minus 6 minus 4, you have minus 10. So here are all these two numbers. So if you make them, you verify that p equals 6 and p equal 4. So just like making sure that this is true. If p is equal to 6, you replace 10, which is going to be this one, the quantity, 10 times 6 minus 6 squared minus 24. And this one is going to be exactly equal to 0 because it's going to be 60 minus 36 minus 24. And if price equal to 4, you have 60 minus 36 minus 24. So then it's going to be 0. Okay, so if the price is equal to 4, then your profit is going to be 0, which is going to be exactly as replacing all these values, and you will find this one, price equal to 4. Then they say, for the break-even price you found in Part C, calculate each resident's consumer surplus. Compare with the mayor's plan who is better off with this admission fee and who is worse off. Explain. So here, first time, the consumer surplus is 24, as we represented before. So then, now this is the new case, where the price is 4, then the quantity demanded for each consumer is going to be 6, then at that time it's going to be 6 times 6, which is the high. This is going to be 36 over 2, which is going to be 18. So then it's better off the first situation for the consumers, because at that time they will have this part. So it's better off this with the consumer, and with this, when they charge a price, then it's better off at that time the museum. So then that time from the consumer side, better the first situation than the other one. Then the last one, I guess, what real-world consideration absent the problem above might provide reason to favor an admission fee. So the point is, when there is a case of lamb sum, you are assuming that all people, they have the same preferences. So all people, they go to the same intensity, intensity to the museum, when at the end of the day everybody pays for the admission through the tax. It doesn't matter if you go once or if you go twice, then it should be a problem. But instead, with the second part, just people that they really want to go, they will be charged. So then this could be maybe the real world consideration, because once that they don't go at all to the museum, they will claim that. Okay, then I guess that those are the first to the 6 point. If you see any mistakes, anything that could be solved in a better way, I really appreciate it. It's just my point of view, and I hope it has worked for you, and see you the next video. Okay, so enjoy the videos, enjoy economics. I'll see you the next time. Bye bye.